Today, many organizations are progressively moving their ICT processes in private and public clouds, motivated by the increasing agility to deploy and withdraw their services without caring about the physical infrastructure that hosts them. The cloud paradigm allows to run applications in a very flexible and cost-effective way. There is no need to buy, deploy and configure hardware, hence saving money and time. The infrastructure as a service model leverages several virtualization technologies to abstract hardware and networking resources. Virtual CPU, virtual memory, virtual storage, and virtual networking are combined together to create virtual machines or other forms of software containers and to interconnect them in an isolated environment, where software can be installed and run in the same way as in physical infrastructure. One of the main operational benefits brought by the cloud paradigm is full control of the virtualization infrastructure through software APIs. The fully digital management workflow allows large automation deployment and lifecycle operations. Orchestration software replaces humans for repetitive tasks, such as provisioning of virtual resources as well as installation and configuration of applications, driven by descriptive models based on imperative or declarative languages that capture the topology and behavior of the service. One major opportunity brought by the cloud paradigm is the possibility to deploy compound services over multiple installations for backup, resilience, and locality purposes. The combination of dynamic provisioning and configuration management software allows to change the service at runtime, so to react to the evolving context, hence providing elasticity, redundancy, and resilience. Most important, such changes can be automated by defining suitable management policies in the service template. Eventually, the ability to adapt to the evolving context makes the service topology partially unpredictable at design time, which may be a major issue for security. The presence of a hypervisor layer, multi-tenancy, and the lack of physical perimeter changed the traditional threat model for cloud applications, raising the question of how to implement security services for virtual environments. Many cybersecurity appliances have been redesigned and re-implemented in the hypervisor layer to cope with virtualization and multi-tenancy. From a purely architectural perspective, this can be viewed as an infrastructure-centric paradigm, because the security appliances protect the physical infrastructure, not the service implemented on top of it. Though this looks the best option for full visibility over the whole virtualization stack, this approach still creates management issues for services that are deployed over heterogeneous infrastructures. The progressive decomposition between the software and the underlying hardware brought by the adoption of virtualization and cloud paradigm has boosted the transition from infrastructure-centric to service-centric architectures, which are more suitable to be integrated in the overall service orchestration process. When the infrastructure as a service paradigm is used, virtual instances of security appliances are plugged into service graphs, leveraging the large correspondence with physical infrastructures that is present in this model. Each tenant retains full control and responsibility of security management for its own graphs, without the need to rely on and trust external services. In some way, this represents a sort of virtual perimeter model, though the isolation from external threats is not comparable with the physical infrastructure. We argue that application to other cloud models is not straightforward, especially when some software components are shared among multiple tenants, for example, as AAS model. Following the need for ever more agility and adaptability to the evolving context of both infrastructure and service layer, the basic principle behind ASTRID is a service-centric framework, with security capabilities embedded into each software element and orchestrated by a common security manager that logically centralizes the detection and reaction processes. To overcome the limitations of current approaches to cybersecurity of virtual services, ASTRID pursues a groundbreaking evolution from monolithic appliances to more distributed and programmable frameworks. ASTRID decomposes cybersecurity appliances into two main components: inspection and detection, the former feeding the latter with a rich security context made of events, logs, measurements. Inspection is further decomposed into many local components to each virtual function, so to create a pervasive and capillary context fabric. Detection is logically centralized to have the best opportunity for correlation in both the time and space dimension. All components are programmable by design, and an overarching orchestration logic enables far more automation than today for prevention and reaction. We're open for collaboration. Download the technical documentation from our website and follow us on our socials. Thank you for watching.